Okay, so for today we are going to walk through these 4 additional identities. I am going to try to go slowly and talk you through what I'm doing and why I'm doing it. So if you guys have any questions, just shoot me an email. Alright, so on number 5, you're going to choose a side. I'm going to choose the left-hand side, and hopefully that's obvious why. The right-hand side is just sine x, so there's not really a lot I can do there. What I'm going to do is first, because this is just one piece, and on this side I have 2 pieces, so I'm going to make this be one piece. I'm going to find a common denominator, and that's going to be 1 plus sine x. So, if my denominator is 1 plus sine x, then this piece would, I need a 1 plus sine x on the bottom and a 1 plus sine x on the top. So I have 1 plus sine x over 1 plus sine x, and then minus that cosine squared x. Okay, and then the next thing that I would do is, because where I'm headed involves only sine, I'm going to change cosine squared x to 1 minus sine x. Now remember the Pythagorean identity says that sine or cosine squared, oh my goodness, cosine squared of an angle plus sine squared of that same angle equals 1. And so what that means is that cosine squared x, we can write that as 1 minus sine squared x. And that's what we're going to use here. So I'll use the Pythagorean theorem and do 1 plus sine x minus, and be careful here, put this in parentheses because you're going to need to distribute that minus sign. So minus 1 minus sine squared x, and this is all over still 1 plus sine x. Alright, and then I'm going to combine like terms. I'm going to get rid of parentheses, distribute that negative, and combine. Actually, I'm just going to do those 2 things. So 1 plus sine x minus 1 plus sine squared x, and this is still over 1 plus sine x. And then the 1's cancel, right? Plus 1 and minus 1 cancel, and you have sine x plus sine squared x over 1 plus sine x. Now, I can see that I could take a sine x out of the top. If I factored a sine x out on the top, that would leave me 1 plus sine x left. And that's really good because that can cancel with the 1 plus sine x that's on the bottom and give me just sine x, which is what I was going for originally. Okay, so that's number 5. I'll leave that there and we'll work on number 7 next. So the first thing that I noticed about number 7 is this 1 plus tangent squared. So I have a couple of options here. I could distribute this cosine squared to both of these pieces. That actually might be a really nice thing to do. Or if I am thinking right, this is one of the versions of the Pythagorean identity, so I could try to use that. I'll actually do that both ways so you can see that, so just in case you didn't see the Pythagorean identity sitting there. So cosine squared x plus sine squared x equals 1. I need a tangent, so I'm going to divide all of this by cosine squared. So I have cosine squared x plus sine squared x. I told y'all I don't have these memorized. I have to do this every time. Divided by cosine squared, divided by cosine squared, divided by cosine squared. So we get 1 plus tangent squared x equals secant squared x. So I can take this 1 plus tangent squared and write it as secant squared of theta here. and that's cosine squared theta times secant squared theta. All right, and then cosine squared theta I'm going to leave alone. Secant squared theta is 1 over cosine squared theta, so this is good news. Those cosines are going to cancel for us, and we get that just 1 back, which is what we're going for. Or suppose you didn't see that Pythagorean identity, so you have cosine squared theta times 1 plus tangent, sorry, 1 plus tangent squared theta. This equals 1. You can distribute this cosine, so you have cosine squared theta plus cosine squared theta times tangent squared theta. This is all still good. And then cosine squared theta plus, this would be cosine squared theta times sine squared theta over cosine squared theta. Those cancel. Now you're looking at cosine squared theta plus sine squared theta, which we know is 1 from the Pythagorean identity. So I guess in either version you have to use the Pythagorean identity, but in this second option you don't use it till the very end, and it's in its standard form. Okay, so there are 2 identities and sort of the thought process through them, right? Like I can distribute things here, or I see this Pythagorean identity sitting here. Can I use it? There's a squared here and a 1, so maybe the Pythagorean identity is sitting there. And then the where you're headed on this one, getting rid of cosine because this side only has sine involved. Those are sort of the tactics that you want to use with some algebra mixed in. Okay, so if we then move on to 6 and 8 here, let's do number 6 first. On this one, the side that you choose does not really matter. I think that there's more to do on the right-hand side because I can't split this fraction up, right? But I can do some stuff on the right-hand side. Oof, this is tricky. I'll do this way, and then maybe we can talk about why it works. So 1 minus cosine t over sine t. There is not a lot to do there. I could split it to be 1 minus sine t over cosine t. Sorry, let me write it down. 1 over sine t minus cosine t over sine t. This is cotangent of t. Ugh, I don't like the t's either. This is cosecant of t. That's not really helpful. I can see here that this looks a lot there. I'd like for the Pythagorean identity to be around, and it's not because nothing's squared. Why would I like for the Pythagorean identity to be around? Well, on the bottom here you have cosine, on the bottom here you have sine, so I need a way to be able to switch those two things. And the same on the top, you have cosine or sine, so finding a way to swap those will be helpful. So what if I make this a sine squared t? If I make that a sine squared t, I can write the bottom using cosine, which is where I'm headed anyway. So if I multiply by sine of t here, I need to do it on the top also. So I have sine t minus sine t cosine t over sine squared t. Again, this is because I would like to be able to convert from sine to cosine, and the Pythagorean identity gives me a way to do that. To use the Pythagorean identity, I need for sine to be squared. So I'm just going to make it b squared by multiplying by 1. You see, I multiply by 1. I haven't changed anything. Sine t over sine t, that is equal to 1. That was one of this step. Sometimes you have to creatively multiply by 1. In this case, it was sine t over sine t, because that gives us something to work with. Okay, so excuse me. Sorry. So sine t over sine t, multiplied by that, you get this. I'm going to go ahead now and rewrite the bottom using the Pythagorean identity. So you're looking at 1 minus cosine squared t. Again, that is from, that's really messy. That's from this. I am rewriting sine squared as 1 minus cosine squared, which is a thing I'm allowed to do. And then on the top, I'm going to factor out a sine t because I see that in common to both of them. So I have sine t out here. And if I took a sine t away from this, I have a 1 that's left, right? You're like undistributing that sign, minus cosine t. So if you were to redistribute this, you would have sine t minus sine t cosine t, which is just what this step is. So I undid that distribution basically. All right. So then what we have is that the bottom, this thing, is the difference of perfect squares. I wrote this down somewhere too for you. Yeah. So the difference of perfect squares is x squared minus 1, or 1 minus x squared. You can factor as 1 plus x, 1 minus x. So that's what we're actually going to use here. And why? So again, talking about why we're headed where we're headed. I would like to cancel this away from the top since I'm close to having what I should have on the top. I'd like to get this out of here. I'd also like a 1 plus cosine t on the bottom. If I factor this, it's going to be 1 plus cosine t, 1 minus cosine t, which will help me cancel and get what I want. So factoring the bottom as a difference of perfect squares, you get 1 plus cosine t times 1 minus cosine t, and the 1 minus cosine t's cancel, and then you're left with sine t over 1 plus cosine t, which is what you were going for. And so that is good to go. So I think, and I'm sure that you guys would agree with me, the ones where you have to pull something out of thin air are the hardest ones, but they're also, it's almost obvious when you need to do that because you like have nothing else to do. In this case, there's nothing else to do, nothing that was helpful. So multiplying by that helps. And if you did it on the other side, you can multiply by sine on the other side as well, which will give you a sine squared on top and allow you to do some similar things. Okay, so number 8, we have, this is really messy, 1 over 1 plus sine x plus 1 over 1 minus sine x equals 2 plus 2 tan squared x. So there may be lots of ways to do this. I'm going to do it the way that I see. There are lots of ways to do this. I'm going to start on the left-hand side. I'm so sorry. Talking is difficult. I'm sorry. I'm going to start on the left-hand side, and I'm going to multiply to get a common denominator. So I need to multiply this by 1 minus sine x. If I do that on the bottom, I need to do it on the top as well, so that I haven't changed anything. So I have 1 minus sine x over 1 minus sine x times 1 plus sine x. And a similar thing over here, I need to multiply by 1 plus sine x because that's the thing I need on the bottom. So now I can combine those. So I have 1 minus sine x plus 1 plus sine x over that common denominator. 1 minus sine x, 1 plus sine x. All right, then you guys were with me on that last step where we had the difference of perfect squares factors like this. You can see that that's the factored form of the difference of perfect squares. So I can write that as 1 minus sine squared x. And then on the top, if I try to combine like terms and such, I would have 1 plus 1, that's 2, and then negative sine x, positive sine x, so plus 0. So I just have a 2 over 1 minus sine squared x. Okay, well, I'm not super close to this, but at least a 2 has popped up, and that's good. So I know from the Pythagorean identity that 1 minus sine squared x is cosine squared. Okay, getting closer maybe. This is 2 times 1 over cosine squared, which is 2 times secant squared. And there it is. Going back to this guy right here, 1 plus tangent squared is equal to secant squared. That's the Pythagorean identity. So I can write this as 2 times 1 plus tangent squared. That secant squared x is equal to 1 plus tangent squared x. And then distribute that 2. And I think that I'm where we were supposed to be. Yes. So a lot of patience and sometimes a lot of trial and error. Some of these are going to be 2 steps. Some of them will be 14. It also is dependent sort of on the route that you take, right? You can get to, I don't know, like if you started on campus and you're trying to go to downtown Charleston, like you could go to Somerville and then back to Charleston, and that's okay, that you would get there anyway. There may be a more direct route, but you could still get there. So that's the whole point of this, is that figure out a way that works for you. What you see is going to be different than what I see. What I think is fastest may be different than what you think is fastest, and that's okay. So just do these slowly. I posted some more problems for you in your written homework. So just give those a look, and if you have any questions, just email me, and I will talk to you soon.